Hey guys, so in today's lecture we are going to discuss geothermal field. So in last lecture we have seen what is the earth made up of, that is mantle, core, crust, and we also seen various distribution of geothermal resources, that where we can easily extract the geothermal resources where volcanoes are erupting, so where we can easily get this resource, but it is available everywhere. So, and we have also seen few applications that for electricity generation and for direct uh, heat application we can use geothermal energy. So today we will see geothermal field. So a typical geothermal field I will draw. So suppose this is a hot magma. This is hot magma. So this is radiating heat from inside the earth in upward direction. Then suppose this is a hot spring. And this is a permeable reservoir. So this is a permeable reservoir. And suppose this is, if we are drilling a well, that is this is a drilled well suppose, and from permeable reservoir we are getting the steam out. So if we are getting steam out from this permeable reservoir, so this is the drilled hole or drilled well. So the amount of thermal energy within the earth is very large, but useful geothermal energy is limited to sites only, as it is not feasible to access and extract heat from a very deep location. Energy present as a heat in the earth's crust within the 10 kilometers more readily accessible heat. Therefore, crust is a potentially useful and almost inexhaustible source of energy. So the temperature of this heat increases with increasing depth below the surface. So the surface down through the crust temperature increases with increasing depth in the earth's crust is 17 to 30 degree per kilometer of the depth. It is 17 to 30 degree per kilometer of depth. So the average temperature of the depth of 10 kilometer is about 200 degrees Celsius, where the heat available near the surface and is relatively more concentrated. Its extraction and use may be considered feasible. Then these sites are known as geothermal fields. So this is a geothermal field. So here a hot magma or molten mass near the surface solidifies into an igneous rock. So this is an impermeable solid rock, and this hot magma gets converted into igneous rock. So groundwater that finds its way down to this rock through fissures, and it will be heated by heat of the rock or by mixing with the hot gases and steam coming out of the magma. So the heated water will then rise collectively upward into the porous and permeable reservoir and above this igneous rock. And the reservoir is covered by a layer of impermeable solid rock that traps the hot water in the reservoir. So the solid rock, however, has fissures that act as a vents, giant underground boiler. Vents show up at the surface as a geysers fumerals, by which the steam continuously vented through the fissures into the ground or hot spring. The natural heat in the earth rises itself for thousands of years in the form of hot springs. A drilled well takes steam from the fissures for use in a geothermal power plant. So the energy available below the impermeable solid rock can be extracted by means of production wells drilled through an impermeable solid rock. So this is the concept of geothermal field. So geothermal gradient. So what is geothermal gradient? It is defined as the rate of increase of temperature with depth. So in a developing country, to use geothermal energy, few factors need to be analyzed. So they are: first, variation of temperature with depths in different parts of the world. So identification of the location at convenient depths from which it is possible to find water, of which having temperature higher than 50 degrees Celsius. So identification of rock that is sufficiently hot and impermeable, which provide extraction of heat and economically feasible. Now we will see types of geothermal resources. So the geothermal resources are classified. So geothermal resources are classified as: first, hydrothermal, that is hydrothermal geothermal resource. Then second, so this resource is up to temperature about 350 degrees Celsius. Then there is a geopressure geothermal resource. So temperature is nearly 90 degrees Celsius to 200 degrees Celsius. Then there is third, there is hot dry rock. Hot dry rock petrothermal, or we can say it as a petrothermal. Hydrothermal, geopressure, and petrothermal resource. It is around 150 to 290 degrees Celsius. Then there is fourth, there is molten rock or magma geothermal resource, that is 650 degrees Celsius. Then there is last, radiogenic geothermal resources. So these are the few types of geothermal resources. So the geothermal resources has temperature from, as you can see, 20 degrees Celsius to 300 Celsius or above. So resources below 150 are usually used in direct use projects for heating and cooling. Ambient temperatures in 5 to 30 degrees Celsius range can be used with geothermal ground source. So heat pumps to provide both heating and cooling. Currently, hydrothermal energy is being commercially used for electricity generation for meeting thermal energy requirements. So now we'll see hydrothermal, that is hydrothermal geothermal resource. So to understand hydrothermal resource, so we'll discuss all these geothermal resources one by one. So we'll start with hydrothermal resource. So to understand hydrothermal resource, we will see this geothermal field again because it is one and the same. So hydrothermal convective resource occurs when where the earth is carried upward by convective circulation. So by convective circulation of naturally occurring hot water or steam under pressure at temperature up to about 350 degrees Celsius. So by convection, if heat is being transferred through water or steam, then it is known as hydrothermal resource. So some high temperature convective hydrothermal resource results from deep circulation of water along the fractures. So this is a permeable reservoir. So this you can see that this is the hydrothermal reservoir where the water is being stored. So hydrothermal resources are located at shallow to moderate depths as far as from 100 meter to 4.5 kilometers. So the water from the rain, lakes, ocean, etc., or several tens or hundreds of kilometers surfaces and surface area percolates into the earth through upper crust and fissures. So in the permeable rocks, so in this permeable rocks to the depths of 2 to 10 kilometers, the water trapped in the porous and permeable rocks underground reservoir or aquifers and heated by surrounding rocks. So heat is supplied by the magma. So this is the heat source due to the upward convection through ingenious rocks. So via the convection through ingenious solid rocks below the porous and permeable rocks, thus it forms a giant underground boiler. The high pressure and temperature water or steam from zero or giant boiler rises through defects or the cracks, fissures in the solid rocks, and hot water or steam often escapes through fissures in the rock, thus forming hot springs, geysers, fumaroles, etc. in order to utilize the hydrothermal energy. Wells are drilled either to intercept a fissure or more commonly into underground reservoir as this is shown. So in order to utilize the geothermal energy, hydrothermal resources are generate electricity. Hydrothermal resources can be further classified into two categories. So we can classify into two categories. So that is first as a dry steam field and second wet stream field, dry steam field and wet steam field. So this use of geothermal energy can be utilized by vapor dominated system, and this uh, resource of geothermal energy can be utilized by liquid dominated system. So this by vapor and this by liquid. So we'll see one by one. So we'll start with the first, it is dry steam field. There is vapor dominated system. So the geothermal fluid for which plants is a dry steam. Dry steam occurs when the pressure is not much above the atmospheric pressure and temperature is high. So temperature is high but pressure is not very much above. So water boils underground reservoir and produces steam at about 7 atmosphere at 7 atmosphere and a temperature between 165 degrees Celsius with low content of particulate impurities and dissolved solid impurities. So these reservoirs are few in number, which the geysers in northern California uh, are which the steam is exploited to produce electricity. So how we can produce electricity from this vapor dominated region? So we'll see the schematic diagram. So suppose this is the geothermal fluid, that is in this case is a steam. So this steam will move towards a steam separator. So this steam will move towards a steam separator. Then this, after going through a steam separator, that is a pure steam, will run the steam turbine. So it will run the steam turbine, and then we can generate electricity while passing through a generator and we'll get electricity. So this is the general layout of process flow, which is going from left to right. So if let's draw various components which will incorporate this flow. So suppose this is the geothermal field. So suppose this is the production well. So where we are getting the steam. So suppose this is the geothermal fluid. So from here it will go to the centrifugal steam separator. So steam separator. So from here the solid matter will move out and only dry steam will move forward in the turbine. So this is the steam turbine. So only the dry stream will move ahead. So after passing through the turbine, so it will generate electricity. It is coupled with an electric generator, so it will generate electricity. So after passing this steam, so it will go to the condenser, so where it will get condensed into water again from steam. So it will convert into water, and then this water is then re-injected back to the well. So now this this steam is cooled with the help of some water through cooling tower. So that cooling tower will also have some water. So that cooling tower, suppose, so this is the cooling tower, so this is a cooling tower. So suppose from here, if cold water is being injected and the condensate cold water is taken back and spreaded uh, to the cooling tower. So the condensate, so that is our hot water is got cooled, and then it will move through a direct contact condenser. So this is the process of the vapor dominated geothermal power plant. Just repeat the process again. So, so the centrifugal separator removes the particulate matter from the steam, and the steam is admitted into the steam turbine. So the steam expands in the turbine buckets, producing mechanical energy, and the low pressure steam at the exhaust of the turbine is condensed in the condenser, and the condensate is re-injected into the earth via the reinjection well. So the cooling water for condensing the steam is circulated through a cooling tower by means of a cooling water pump. And the reasons to reinjection of condensate into the earth are: first, why we are reinjecting it back to the earth. So to ensure the supply of fresh water from production well for several years, the earth acts as a steam generator to prevent environmental pollution, and the condensate contains certain pollutants. Example, steam at geysers contain hydrogen sulfide. If condensate is left out on the ground layer, it causes environmental hazards. So, geothermal energy in the form of dry steam is converted into mechanical energy by the turbine, and the mechanical energy is converted into electrical energy by generator. And the synchronous generator generates electric power at a high voltage 50 Hz AC supply. So this power is transmitted by a system fed by 30 supply network. So steam geothermal power plant is grid connected and operated continuously as base power plant. So this is the whole idea of geothermal power plant. This is the vapor dominated. So we'll see wet dominated also in the next lecture. So thank you very much.